Hello and welcome to my channel. This is Jasmine Gonzalez. I'm going to be doing an experiment called Elephant Toothpaste. This is for the benefit of my students who need to do catch up doing virtual labs. But if you're new to my channel, welcome, and I hope you like this video. I'm not going to be adding dish soap and all that kind of stuff. I want to keep the reaction simple, quick. So dish soap is optional. It's not going to affect the reaction. The reaction is still going to happen. So kinetics is the study of rate of reaction, transfer of energy during chemical reactions. In this reaction, yeast will be used as a catalyst to remove oxygen from hydrogen peroxide. What happens is yeast has an enzyme, and that the enzyme is called catalase. And catalase pretty much breaks down hydrogen peroxide relatively fast. And hydrogen peroxide formula is H2O2. When the oxygen is removed in a decomposition reaction, water and oxygen gas are the products. This reaction does happen naturally over time, but the reaction is slow. And that is true. So you purchase hydrogen peroxide. It still works for a period of time. It has an expiration date. If you keep this in a cool, dry place, it will last you for a while. After a certain period of time, this will no longer work. So usually the expiration date is in the package, and I think you can see it right there. And it says that it expires in 2028. So takes a while before it's no longer useful, doesn't have any effects. So what we're going to do is we're going to use yeast as a catalyst, and let me explain what happened. So a catalyst does is it lowers the activation energy needed for a reaction to happen. If you were previously paying attention in class, or if you are new to chemistry, so what happens is for a reaction to happen, this is the case of an example of an exothermic reaction. You have the reactants, they have a certain energy, every chemical has a certain potential energy. So when a reaction happens, you need to add some energy for that reaction to happen. And sometimes, for example, if you want to decompose hydrogen peroxide, you can add heat, but that will require a lot of energy, or maybe you want the reaction to happen faster, so you can use a catalyst. That way the reaction happens faster, and also the energy that you need to add for the reaction to happen is less. So you can see that here the blue lines represent the activation energy needed with a catalyst, and the red lines represent the energy that you need to add with a catalyst. So you are adding less energy for a reaction to happen, and that way you get the products. And this here represents the enthalpy change of the reaction. So knowing that, what we're going to do is we're going to use observation to determine this reaction is endothermic or exothermic. An endothermic reaction absorbs heat and therefore feels cold. An exothermic reaction releases heat and therefore feels warm. So these are the pre-lab questions. So here's your decomposition reaction for the hydrogen peroxide. So 2 moles of hydrogen peroxide will produce 2 moles of water and 1 mole of oxygen gas. Now the system of this experiment we're going to be looking at is hydrogen peroxide and the enzyme catalase. So this is my system, hydrogen peroxide. The surround is going to be the water that surrounds the molecules of hydrogen peroxide, and the flask. And we're going to measure the temperature of the water and the flask. We're going to see that. And I don't know why my camera just pretty much like. I'm trying to. So. I'm trying to refocus my camera. There we go. So. If the removal of oxygen from hydrogen peroxide is endothermic, what will be observed? So we already have the answer from there. If it's endothermic, the temperature will probably decrease and the flask will feel cold. If it's exothermic, the temperature will increase and the flask will feel hot. So I already got the yeast in here, sitting here for a while. I'm going to measure some hydrogen peroxide and I'm going to take the temperature. So I will set up the phone over here. This is a liquid, so I'm going to add some hydrogen peroxide to the beaker. I'm going to go into about 120 milliliters. That's a lot of hydrogen peroxide. But then again, because it's only 3%, it's not completely a lot of hydrogen peroxide. That's enough hydrogen peroxide in there. And here, I'm going to measure the temperature of the hydrogen peroxide first. So, recording the temperature. And that will be my initial temperature in there. So my initial temperature of this is about 24.5 degrees Celsius. Like if you look here, 10 mark is right there, 20 is up there, and the line is between 24 and 25. So I will say 24.5 is my initial temperature. I'm going to come here to the lab sheet and record that. So that the initial temperature is going to be 24.5. Alright, so I'm going to take this out. We're going to measure the temperature again at the end of the reaction. So right now I'm going to add the hydrogen peroxide. This is going to be messy, that's why I have this here. And we're going to see what happened. So here we go. Ready? 1, 2, and 3. There we go. You can see that quickly. We can see that this is fizzling relatively quickly. This is going to be a messy reaction. Yep, I'll have to clean this. If you add the soap, it's just going to send it straight into the air. I didn't want that to happen. So you can see the bubbles forming. That bubbles indicate a reaction, in this case oxygen being formed in the reaction. Like if you remember a few minutes ago, the composition of hydrogen peroxide produces water and oxygen. So these bubbles have oxygen in them. Oxygen gas, what is in the air? So we're producing oxygen. I'm going to measure the temperature. So I'm going to stick my thermometer in there and let it rest for a little bit, for about a minute before taking the temperature. You can see probably the temperature rising in there. You can see the temperature is rising. This is the 20 mark. Oh, so shit, temperature process. Shoot. Alright, so I will record the temperature now. Don't think it's going to increase more. So the temperature is going to be here 20, 21, 22, it says then 23, so 22.5. 22.5. So temperature is 22.5 and 22.5. Now I want to apologize because that was not the initial temperature, was not 24.5. The initial temperature was below the 15 mark, so it's 14.5. That was the temperature initially, so fix that. It's not 24.5, just cross it out. It was 14.5. The temperature rose to 22.5. So this increase in temperature proves that the reaction is exothermic. That's what you will expect in an exothermic reaction. Heat is going to be released from the system, which is hydrogen peroxide, and it's increasing the temperature of the surrounding water. in the system. The observation, so we're going to write after hydrogen peroxide was added to the yeast, bubbles form. That's good enough for observation. So now we're going to calculate the density of the hydrogen peroxide. We're going to determine the mass of hydrogen peroxide using the reaction. So we use about 120 milliliters, and we know that the density is 1.2. So we're going to multiply that by 1.2 to find the mass. So 120 milliliters divided by milliliters, it cancels out. So 1.2 times 1.2 times 120, that's going to give me the mass of the hydrogen peroxide. I have a calculator here. Good for me. So clear. So 120 times 1.2, 144. So the mass uses 144 grams of hydrogen peroxide. Assume the specific heat is of hydrogen peroxide, joules divided by grams per Kelvin. How much heat energy was absorbed or released? So in this here, we're going to use the heat equation, which is Q, which is mass, times C, which is the specific heat, times the change in temperature. So we know that the change in temperature is equal to the final temperature minus the initial temperature. So 25 degrees, 22.5 minus 14.5. So the mass is 144 grams. So, and the C is just this, so we're going to put that in the equation. So 22.14.5, this is my temperature. The mass is 144 times 2.619. So I'm going to put this in the calculator. I'm going to show you clear. So we're going to put 144 times 144 times 2.619 times parenthesis 20.5 times minus 1.5. That's equal to, and is 3017. So this will be 3017 joules, and this is going to be positive. Is being released. This is the energy release. So it was released. So this amount of energy was released. This is what caused the temperature to increase in the experiment. And now we're going to answer the final questions. We're not going to do this one, number 3. Is this reaction endothermic or exothermic? So this is an exothermic reaction. Exothermic. The 2 pieces of evidence that support this claim is, I'm not going to touch that because I don't want to feel heat, but temperature increased, and the heat was released. Draw a sketch of potential energy diagram for this reaction based on your data. So this we have the energy, potential energy. And this is similar to the first graph that I showed you. And you have the reactants, you have the products. This is the exothermic reaction. So you draw one that it will be bigger, one curve that is bigger, first one over here, and that will be the activation energy without enzyme or the catalyst. And in here you will draw another one similar to that one but a little bit smaller, and that would be the activation energy required with the enzyme or the catalyst. So, and now you're going to write in your own words, you're going to write a conclusion to explain your results and what did you expect, if you expect anything different, and write what you learned pretty much from watching these experiments. As you can see, we have learned that the composition reaction of hydrogen peroxide with yeast is an exothermic reaction. We know that because when we did the experiment, we measured the temperature, and that temperature increased, and we can tell, and that gives us the evidence needed to support our claim, to support the determination that this is an exothermic reaction. In addition, we saw oxygen being formed. We know that a reaction happens because oxygen was formed producing bubbles and causing this fascinating reaction to happen. Alright, so write that down, write your conclusion, and that's it. Any questions? Feel free to ask me in class, and have a great day. Bye.